Good morning, students. We will continue the chapter number 2, sets. In this chapter there are many topics related to sets. Among that we have already studied the subsets topics as well as power set, which is related to subsets, and the last topic which is related to subset is our proper subset. Okay, what do you mean by proper subset and what do you mean by improper subsets? If you are studying the proper subset, then you will understand improper subsets also. Now, what is the definition of proper subsets? For set A and B, let set A and B, two sets which are given here. If A subset B, that means all the elements of set A are in set B, and the second condition is A does not equals to B and A does not equals to B, then A is called a proper subset of B. If A subset B and A does not equals to B, then A is called a proper subset of B. A is called a proper subset of B, and B is called superset of A. If A subset B, then A is a subset of B and B is a superset of set A. It is known as superset of set A. In this case, there are two conditions, A subset B and A does not equals to B. Then A is called proper subset of set B and B is our superset of set A. For example, I am taking first example, set A equals to 1, 2, 3. Here three elements of set A, 1, 2 and 3 are there. And set B equals to 1, 2, 3 and 4. Four elements of set B are there. See here, 1, 2 and 3. Three elements of set A means all the elements of set A are in set B. All the elements of set A are in set B. Therefore, we can say that A is subset of B. Therefore, we can say that A is subset of B. It is clear? Now, check that A equals to B or not. So, see here, A equals to 1, 2, 3 and B equals to 1, 2, 3, 4, which are not equal sets. First one, A is subset of B and A does not equals to B. A is subset of B and A does not equals to B. Then we can say that A is a proper subset of B. Then we can say that A is a proper subset of B. If A is not a proper subset of B, if A is not proper subset of B, then we can say that it is an improper subset. It is improper subset. The second example here, set A equals to 1, 2, 5. Set A having elements 1, 2 and 5. And set B also equals to 1, 2, 5. Set B having 1, 2, 5. Now see here, all the elements of set A are in set B. All the elements of set A are in set B. Therefore, we can say that A is subset of B. A is subset of B. Now, 1, 2 and 5 are elements of set A as well as 1, 2 and 5 are the elements of set B also. Therefore, they are equal sets because all the elements of set A and B are equal. Therefore, set A equals to B. So here A is subset of B and A equals to B. Then A is an improper subset of B. Okay, if A is not proper subset, then we can say that it is improper subset of set B. Now, I am giving some examples related to this topic which are not given in your textbook. So see here, list out all proper subsets. List out all subsets, proper subsets, all proper subsets of set A which is equals to 1, 2. First of all, I am listing out all the subsets of set A. So first of all, list out all the subsets of set A. Subsets of set A. So we know that here set A having two elements, therefore number of subsets of set A equals to 2 raised to n, which is equals to 2 raised to 2 is equals to 4. So we know that 4 subsets of set A, which are, first one is null set, second one singleton set, third one also singleton set, and fourth one this set itself. We can say that set A, or you can write curly bracket 1, 2 also. Now see here, there are 4 subsets of set A. Among these, list out the proper subsets only. List out the proper subsets only. For the proper subsets, these will be the subset of this, and it is not equal to that set also. Means this is the subset of this, and it is not equals to this set A, then we can say that it is proper subset. So see here, 5 is the subset of set A but not equal, therefore it is proper subset. Next one, curly bracket 1 is the subset of set A but not equal, therefore it is also proper subset. Curly bracket 2, which is also subset of set A, therefore it is proper subset. Not equals to set A, therefore it is proper subsets. And the last one, curly bracket 1, 2, or set A, which is subset of set A, but they are equal, therefore this is not a proper subset. Okay, this is improper subset. Okay, this is improper subset. Therefore, I am listing out the proper subsets of set A here. Proper subsets of set A are, the first one, null set, curly bracket 1 and curly bracket 2, all 3 subsets which are proper subsets of set A. And if I am listing out the improper subsets of set A, I am listing out improper subsets of set A which are only set A. Okay, therefore we can say that the set itself is the subset of any set. The property is that set itself is the subset of any set, and it is improper subset. It is improper subset. Okay, rest of the other which are proper subsets. Now see again second example related to this topic. List out all proper subsets of set A equals to A, B and C. Of set A which is equals to A, B and C. So first of all, I am listing out all the subsets of set A. Subsets of set A. So list out all the subsets of set A. We know that set A having 3 elements, therefore number of subsets of set A equals to 2 raised to 3, which is equals to 8. So list out all the subsets of set A. Here 8 subsets are there. First one 5, curly bracket A, curly bracket B, curly bracket C. Now list out the subsets having 2 elements which are AB, next one AC, next one B and C. Now list out the elements of set A, B, C. Now having 3 3 elements, which is also known as, this is set A. You can also say that this is set A. You can write like this also. Okay. Now see here, total 1, 2, 3, 4, 5, 6, 7 and 8 subsets are there. Now we are going for the improper subsets of set. First of all, I am listing out the improper subsets of set. Improper subset of set A, which is set A only, which is set A only. Now rest of them which are proper subsets, rest of them which are proper subsets. Therefore, list of proper subsets of set A, proper subsets of set A are, first one, null set, curly bracket, A, B, curly bracket, C, curly bracket, AB, curly bracket, AC, curly bracket, BC. Okay, total 1, 2, 3, 4, 5, 6, 7. 7 subsets which are proper subsets, and the set itself is our improper subsets. Okay, now we are going for the formula. How can we find the number of proper subsets of any set? Okay, but here the number of improper subsets, of any given set equals to 1 only. The set itself, it equals to 1 only. Number of improper subsets equals to 1, which is set itself only. Now rest of them which are proper subsets. So we know that the number of total subsets equals to 2 raised to n. Total number of subsets which is equals to 2 raised to n. Subtract one improper subset from total number of subsets, we are getting the number of proper subsets. Therefore, the number of proper subsets of any set which is equals to number of total subsets, the number of total subsets minus number of improper subsets. Okay, number of improper subsets. We know that the total number of subsets which are 2 raised to n, and the number of improper subsets which is 1. Therefore, how can we obtain the number of proper subsets? This is the formula for obtaining the number of proper subsets, which is equals to 2 raised to n minus 1. Okay. Now we are going with the 3 MCQs related to proper subsets and improper subsets. The first MCQ is the number of proper subsets of set A equals to curly bracket 5. Okay, so we have to find the number of proper subsets. We have the formula, the number of proper subsets of any set equals to 2 raised to n minus 1, where n is number of elements of that set. Here set A equals to curly bracket 5, therefore set A equals to curly bracket 5, therefore number of elements in set A which is equals to 1. Total number of elements in set A equals to 1. Now the number of, we have the formula, by using the formula we can calculate it, the number of proper subsets, the number of proper subsets, here subset is there, proper subsets of set A equals to, formula is that 2 raised to n minus 1. Now put n is equals to 1 here, 2 raised to 1 minus 1, which is equals to 1. There is only one proper subset. Okay. Now the next second MCQ, the number of proper subsets of set A equals to null set or phi. Set A equals to null set or phi. Therefore, for finding the number of proper subsets, first of all, find the number of elements of set A. So here set A equals to null set. Therefore, number of elements in set A, which is equals to 0. Now use the formula, the number of proper subsets, the number of proper subsets of set A which is equals to, the formula is 2 raised to n minus 1. Put n is equals to 0 here, 2 raised to 0 minus 1. We know that the power 0 of any non-zero number is equals to 1. That means 1 minus 1, which is equals to 0. Here number of proper subsets equals to 0. Therefore, the answer is 0, option number A. For this, option B is right. Next one, the third question. The number of improper subsets of set A equals to null set. So we know that there is one improper subset which is set itself only. Okay, therefore the number of improper subsets of set A is 1. The option B is right. Okay. The next one topic is universal set. You have studied this topic in standard 9 also, and this topic is very easy for you. The definition of universal set is not given in textbook, and the definition is not too much important for us. We can understand it directly. For the set of prime numbers, suppose we are consider the set of prime numbers. We are also deal with set of even numbers. We can also deal with set of odd numbers. Okay, here prime numbers, even numbers, odd numbers. Okay, and we can deal with them. The relations between odd numbers and even numbers, relations between prime numbers and even numbers, we can deal with them. Okay. For dealing with them, we are considering some reference set. We have to consider the reference set. Among that reference set, all the sets which are prime, even or odd from that set. Okay, the reference set is known as our universal set. Here, set of prime numbers which are the part of natural numbers, set of even numbers which are also part of natural number, set of odd numbers which are also a part of natural numbers. Therefore, the set of natural number is our reference set, and this reference set is called as universal set. Okay. Now, if we are calculating the human population, okay, for the study of human population, the universal sets consist all the people in the world. For studying the human population, we have to consider all the people in the world as a reference set. Okay, then we can bifurcate them, the population of India, population of Australia, population of America, but we have to take the reference set, which is known as universal set, as a total people of the world. Next, if we are discussing the results or marks of 11th science in any subject, so we have the reference set, the marks of total 11-12 science stream. This is the reference of our set. Therefore, the total marks or results of 11-10 science or science stream is our universal set. That means we have to consider that set which having all the elements of the given sets are in that. Okay, this is our universal set or reference. Now, exercise 1.3, question number 8. what universal set or sets. You can take many universal sets, okay, or you can take only one universal sets. Would you propose for each of the following? First one, the set of right triangles. The set of right triangles. So the set of right triangles we having, there are many set of right triangles having sides 3, 4, 5, 6, 8, 10, okay, 5, 12, 13. There are many right triangles having different size. I am considering the reference set for the right triangles, the set of all triangles, the set of all triangles in a plane. The set of all triangles in a plane. I am considering all triangles. Therefore, in all triangles, right triangles are there. Okay, therefore this is our universal set for the right triangles. It is clear. Next one, the set of isosceles triangle. We can also take the set of all triangles in the plane. The isosceles triangle having all the sides. Isosceles triangle having two sides are equal and the other is different. So in the isosceles triangle, there are different isosceles triangle is there, or we can consider the set of all triangles in a plane as a universal set or reference set. The set of all triangles in a plane. Therefore, set of right triangles as well as set of isosceles triangle, we are considering the universal sets of both of them, the set of all triangles in a plane. Okay. The next one, exercise 1.3, question number 9. Given the sets, set A equals to 1, 3, 5, set B equals to 2, 4, 6, and set C equals to 0, 2, 4, 6, and 8. Which of the following may be considered as universal set for all three sets A, B, and C? Now, for set A, B, and C, which of the following? There are four options given here. Select one proper or other, if possible, universal sets. Okay. One or maybe more answers are possible for this case because they are given that universal set or sets. Okay. Therefore, you have to select all the possible answers among the given options. The first one, set A 1, 3, 5, set B 2, 4, 6, and set C 0, 2, 4, 6, and 8. So we have to consider reference set or universal set having all the elements of set A and set C also. Set A, B, and C also. Therefore, we can take the set as 0, 1, 2, 3, 4, 5, 6, and 8. 0, 1, 2, 3, 4, 5, 6, and 8. We have to take that set only. See here, first set 0, 1, 2, 3, 4, 5, 6 is there, but 8 is not there. Therefore, we cannot consider this as a universal set because 8 is the element of C but not in our universal set. Therefore, the first option is wrong. Second one, null set, which is always not possible because they are the sets having 3, 5 elements or 3 elements. Okay. Next, third one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. See here, all the elements of set A 1, 3, 5. So here 1, 3, and 5 are there. 2, 4, and 6. So 2, 4, and 6 also there. 0, 2, 4, 6, 8. 5 elements 0, 2, 4, 6, and 8 are there. Therefore, we can consider the third option as a universal set or reference set. For the next one, check it out. 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 3, 5 of set A all the elements of set A are in this, but Here 0 is not there for the set C. 0 is not there, therefore we cannot consider the fourth option as a universal set, because we have all the elements in universal sets of set A, B and C also. Okay. The question exercise 1 question number 1 is related to topic subset. Therefore we are considering here. Decide among the following sets which sets are subsets of one and another. Okay. The first set, set A equals to x such that x belongs to R. X satisfy x square minus 8x plus 12 equals to 0. Set B equals to 2, 4, 6, set C equals to 2, 4, 6, 8 up to infinite, and set D equals to 6. First of all, write the set A in roster form. For writing the set A in roster form, we have to find all the possible values of x which are satisfying this equation as well as real numbers. Okay, therefore finding the possible values of x square minus 8x plus 12 by using the splitting the middle term, 6 to the 12 and minus 6 minus 2 which are equals to minus 8. Therefore splitting the middle term. Okay, now you can take x common from first two terms, therefore the rest of terms are x minus 6. You can take minus 2 from these two terms, therefore remaining terms are x minus 6 which is equals to 0. Now you can take x minus 6 common from these two terms, the rest terms are x minus 2 equals to 0. Two brackets multiplication equals to 0, therefore we can say that x minus 6 equals to 0 or x minus 2 equals to 0, any of them equals to 0. Therefore we having x equals to 6 or x is equals to 2. Therefore set A equals to 2 and 6. Set A equals to 2 and 6 are there. Okay, set A having two elements because they are real numbers also. Okay, now set A equals to 2, 6, set B equals to 2, 4, 6. Therefore we can say that all the elements of set A are in set B. Therefore A is subset of B. Now check, A is subset of C or not. So here all the elements of set A which are 2, 6 in the set C. Therefore A is also subset of set C. Now check for A subset of D or not. So here 2, 6, all the elements of set A are not in set D because 2 is not in set D. Therefore A is not subset of D. As next one, set B. Consider the set B. Set B is the subset of set A or not? So set B having 4 but set A does not contain 4. Therefore we can say that B is not subset of A. As well as B is subset of C. Here all the elements of set B are in set C. Therefore B is subset of C. Okay, next one, C. C is the bigger sets of given among sets. Therefore C cannot be subset of any set A, B or C. Okay, next one, set D. Now D is the subset of set A or not? Here D is subset of A because all the elements of set D are in set A. And set D is also subset of set B. Set D is subset of B, as well as set D is also subset of set C. So there are possible subset pairs we have written here. Okay, this one is your answer. Clear? Thank you very much.